Okay, in this video we're going to look at the volumes of prisms. There are lots of different kinds of prisms. What a prism is just a solid which has the same cross-sectional area along its length. So we have a few drawn out for us, lovely drawings here, so we're going to show what I mean here. So if you imagine if you slice this thing vertically and then you looked at the slice, it would have the same shape as it had at the first end. So if you sliced it anywhere along, it's going to have the same shape all the way through. So if you're looking at it, likewise here, I'll not do the circular one because it's going to be trickier to draw. But if you sliced vertically here on this triangular prism, very roughly that's what it's going to look like, and you can see it would have the same shape all the way through. Or if I slice this one down here, it would have very roughly the same shape, would have the same shape all the way through, but you can see I've done a very rough diagram. So slicing it all the way through, the same, what's called cross-sectional area all the way through. Now the volume of a prism is equal to the cross-sectional area times the length of the shape. So we've left one of these up here. We've done our trapezium one here, so we've got, you would find the area of this cross-section, and then you would multiply by the length. Okay, so this is the cross-sectional area, and this is the length L. So we're going to look at a couple of examples now on how we actually put this into practice. Okay, this says find the volumes below. So if you haven't watched the previous video, which was on the area of shapes, watch that again because you need to know the areas of shapes to be able to find the volumes of prisms. Remember, you're going to be finding these cross-sectional areas here, and then once you've done that, you just multiply by the length. So first of all, in this one, I'm going to work out the cross-sectional area, CSA. Now, if you think about what kind of shape is it, it's a triangle, so it's going to be a half times base times height, and then in this case, it's a half times 3 times 5. 3 times 5 would be 15, times that by a half is going to be 7.5. So your volume is equal to your CSA, your cross-sectional area, times your length. So in this case, it's going to be 7.5 times 10, because your length is 10, that's your length here. So times 10, and if you do that, it's going to give you 75, and the units are going to be centimeters squared. Okay, for this one, tricky enough one that people struggle with at times, it's got a trapezium cross-sectional area. Cross-sectional area then, for area for a trapezium, go back and look at the video, is a half upon A plus B times H, where A and B are the parallel sides. Now it's not obvious maybe on this one. One of the parallel sides is fine, it's 3.5. The other one not so easy, but if you drag this 1.5 along here, this dimension here is also going to be 1.5. So I'm just going to label that to make it really clear. That's 1.5 centimeters. So 3.5 plus 1.5 in the bracket, and the perpendicular height, so it's a perpendicular distance between them, so it's going to be this 2. So times 2. So that's going to be a half times 3.5 plus 1.5 is going to be 5 times 2. And then a half times 2 is just 1 times 5 just gives you 5. Okay, your volume is your CSA times your length. So it's just 5 times 9, which is 45 centimeters squared. Okay, we're going to look now at a cylinder. A cylinder, it says here, is the most common prism, and its volume is pi r squared h. Okay, let's think about why this is. Let's just draw ourselves out a wee cylinder, which has a radius of r, and it has a perpendicular height of h. Now the cross-sectional area of the cylinder is a circle, and the area of the circle is pi r squared. The length of the cylinder is h, so your volume is equal to the cross-sectional area times your length. So in this case, it's pi r squared times h, and you can just push those together to give you pi r squared h. So your volume is equal to pi r squared h. So it's a very easy formula. I would learn that for a cylinder. Volume is equal to pi times r squared times h. So in this case, it says find the volume of the cylinder below. Volume is equal to pi r squared h. So it's going to be pi times 6 squared times 12. And if you do that on your calculator, what you will get is 400, and it'll come out as 432 pi. This is very important, folks. This is an exact perfect answer. Okay, and then what you maybe want to do is give it the 2 decimal places, as I've done here. And I'm just going to check my answer here. It's 432 times my pi. So press the SD button and you'll get 1357.17 centimeters squared, and put in brackets the degree of accuracy, brackets 2 dp. Okay, this example we've got a prism, and we have to find the volume of this prism. So we're going to have to work this out. So we have got, I'm going to put this into 2 bit cell. You've got your shape 1 and you've got your shape 2. So shape 1 and shape 2 make up the cross-sectional area. So we're going to have to work out these shapes first of all. So for 1, let's look at 1. The area is, it's a semicircle. I'm just going to say a half circle here, and then we're going to work that out. So it's going to be a half times the formula for a circle, which is pi r squared. And for this particular semicircle, the radius of this semicircle is a half of 23. So it's going to be 11.5 squared. So if you do that out on your calculator, what I got was 207.7378. So I've gone to more than 2 decimal places because I'm going to be using this as part of my answer. Okay, area 2. So 2 is just a, well, what is 2? 2 is a rectangle, so it's just length, or what's not what we normally say. We say normally base times height. We'll go with that still, base times height. So the base is 23 and the height is 17. So if you do 23 times 17, you get 391, sorry. So we'll just say our total cross-sectional area is equal to 391 plus the 207.7378. And if you do that out, what you're going to get is 598.7378. Now your volume, now we're on to the actual thing we wanted to find. It was volume is cross-section area times length. So 598.7378 times the length, which is 32. And if you do that out, you'll get 19159.61 centimeters squared. And I've given my answer correct to 2 decimal places. Okay, now we're on to some really good examples here. Some proper mathematics questions here. It says a cuboid has a volume of 40 centimeters cubed, a length of 5 centimeters and width of 2. Work out the height of this cuboid. Okay, right. A question I guess is really good because you're not really too sure how you're going to do it, but you think about what we've been told, or what we're talking about. We're talking about a cuboid and its volume. So what you want to do here is think about any formulas you know for the volume. So a cuboid, the volume of a cuboid is length times breadth times height. And then what we're going to do is read through this question again, this example, and see what we actually know. So the first thing we know, it says it has a volume of 40 centimeters cubed. So that means we replace our volume in our formula, the V part, by 40. Next thing we know is it has a length of 5. So we replace the L, the length part, by 5. And it has a width of 2. So we're going to use that as our breadth. So times 2. And then we have to work out the height. So we want to find h. So what we've done is we've taken our formula, written down our formula, and then we've subbed in what we know. We've substituted in all of the different bits of information that we actually know. And this one works out very nicely because you've got 5 times 2 works out to be 10 times h. And then what is this 10 doing to the h? It's clearly multiplying. So when it goes across to the other side, what it's going to do is divide. So 40 divided by 10 is equal to h. And then your h works out to be 4. And the units are going to be centimeters. So a lovely, lovely example. So let's just go through that again. What we did, we found our we wrote down our formula. We looked at the question that said we were talking about the volume of a cuboid. So you write down your formula. Then what you did, you filled in what you knew. You knew the volume was 40. The length was 5. Our width, or breadth in this case, was 2. And you need to work out the height. So write down your formula, fill in what you know, and then solve the equation to get to your answer. Okay, this example says the diagram shows a cylinder. The radius of the cylinder is r. The length of the cylinder is 0.1 meters. The volume of the cylinder is 140 centimeters squared. Find r. Okay, no idea. So let's just go through the question again. It's a cylinder, and it tells you the volume of the cylinder is 140. So the first thing I'm going to do is write down my formula for the volume of the cylinder, which is V is equal to pi r squared h. And then it's the bit that's underlined still says volume of the cylinder is 140. So I'm going to replace my V with 140. Pi, I can't replace it, but it's on my calculator. R is what we're trying to find, so we're just leave it. And we know the length of the cylinder is 0.1 meters. So 0.1 meters, say height is equal to 0.1 meters. Convert that into centimeters first. That is 10 centimeters. So that's times 10. Okay, sort this out. We have got 140 is equal to, I'm just going to bring the 10 across, 10 pi times r squared. Now this is a fairly tricky bit of maths here. So what we're trying to get is r on its own. Now there's two things now which are happening to r. The first thing is being squared. The next thing is it's being multiplied by 10 pi. So being multiplied by 10 pi is the first thing that we have to reverse. So what we want to do is write 140 divided by 10 pi is equal to r squared. Okay, now we have to reverse that squaring. So r is going to be equal to, the opposite of squaring is square rooting, and it was 140 over 10 pi. And then we do that on our calculator and see what you do. So on your calculator, hit your square, if you're using a half-decent Casio calculator, hit your square root button, and then hit your fraction button. So you should have now square root, and then 2e squares, blank squares inside. On the top square you put 140, and the bottom square you put 10, and then you hit your pi button. What you should have is square root of 140 over 10 pi, press equals, and what you should get is 2.1110041123, which is 2.11 centimeters to 2 decimal places. Okay, folks, you now know how to find the areas of all kinds of prisms. Remember, volume of all kinds of prisms, I should say. Volume of a prism is just your cross-sectional area times your length, and you may need to use some of your area formulas to find the cross-sectional area.